The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Good morning, students. I know you all are very busy with your work and hope you are safe and your parents are also doing good, and missing you all a lot, children, because at this time we all will be engaged very hardly in Kalolsavam practice and maybe work experience, fair. We are really missing all those golden moments, but still just waiting for a better opportunity for us to come back again. Like we are going to have a great moments once you come back to us with great energy. And I think you all are on par with the syllabus. I have been sending you the bullet points of the first 3 chapters, and I think that might be useful for you. Also, I will be sending you the solved question answers which you can study for your board exam as well. So let us begin today's class. We were starting with the 5th chapter, surface chemistry, and we started with the term adsorption. Yes, what is adsorption? Can anybody tell me? Arya? Yes, adsorption is a process where the surface of the solid gets accumulated by a substance, and the surface where it gets accumulated is called as an adsorbent, and the substance which gets accumulated is called as an adsorbate. This is what we studied, and the process is commonly called as adsorption. We also learnt about the difference between adsorption and absorption. Then we came to physisorption and chemisorption, mechanism of adsorption. In physisorption and chemisorption, we learnt the basic difference between those two, which is very important in exam point of view. You must be learning at least minimum 3 to 4 differences between the two with example. And we also started with adsorption isotherm. You remember, children, Freundlich adsorption isotherm? Yes. So that also we were studying, and today we are going to learn something which we already know, right? But we were not sure about the mechanism that was happening. So today it's a very interesting topic. You will be having videos along with the content, so which will give you a more clear idea, a crisp knowledge of what is catalysis. So today's topic is catalysis. We know what are catalysts. We have been learning from 9th, 10th standard, right? Catalysts are substances which will disturb the rate of reaction. When I say disturb, it alters the rate of reaction. It can increase or it can decrease. That is called as a catalyst. It's actually a foreign substance. Foreign substance means not coming from abroad. Foreign substance means which is not required for that particular reaction, because we know reactants react at a particular temperature and pressure to give the products. So what is the role of a catalyst? We are going to see. This is an example which is given in your textbook, where potassium chlorate on heating strongly decomposes to form potassium chloride and oxygen. It releases oxygen to the atmosphere. Now this actually takes place at around 653 to 873 Kelvin. That was the temperature at which this reaction happens. But when manganese dioxide was added along with this reaction started occurring at low temperature, means the product was formed very soon. We could yield the product at a faster rate. So the temperature came down to around 473 to 633 Kelvin. So then scientists, when they understood that there is something which when added, a foreign substance or something that is not required for the reaction, when it is added, the reaction is altered, the rate of reaction is disturbed. It can either accelerate or it can reduce the rate of reaction. So then Berzelius was a scientist who studied about this process, why when such substance added disturbs the rate of reaction in 1835. Then he gave that foreign substance a name which is called as catalyst. So what is a catalyst? This is a definition for the catalyst. Substance which accelerate the rate of chemical reaction and themselves remain chemically and quantitatively unchanged. Both these words important, chemically and quantitatively. When I say chemically, what does it mean? Say when I am going to add manganese dioxide to this reaction, if manganese dioxide is reactive, it should also react with potassium chlorate and I may not get my desired product. I may get some other products along with the desired product. So this catalyst which I am adding, after the reaction gets over, it does not react with the reactant. It remains unchanged chemically. Whatever composition I am putting, the same composition I am getting it back after the reaction. And quantitatively say assume I put say 40 grams of manganese dioxide, but I get the same 40 grams back after I get my reaction over or after I get my products done. So along with my products, I get my catalyst also back chemically and quantitatively unchanged. So such a substance we call it as catalyst, and the whole process of adding a catalyst during the reaction and after getting the product along with the catalyst, we call this process as catalysis. So what is catalysis? The process of adding a catalyst, thereby getting the products and the catalyst remaining chemically and quantitatively unchanged. Now when I say catalyst, there are two types of catalyst. In 10th standard, we learnt about positive and negative catalyst. You remember children? Positive catalyst increase the rate of reaction, negative catalyst decrease the rate of reaction. So here another term which we are going to learn here is promoters, poisons. Promoters, what do you mean by promotions? You get promotions means you get upgrading yourself, right? You get appraisals, you get promotions, offers. So promoters means which promote, which increases the rate of reaction, which enhances the activity. And what are poisons? Poisons are something which is toxic, which does not allow the reaction to take place at a good rate. They decrease the rate of reaction, they reduce the rate of reaction. Such substances we call it as poisons. It comes in 1 mark question. So remember what are promoters and what are poisons. They both are catalysts. This enhances the reaction and this decreases the rate of reaction. Now we are going to learn about the types of catalyst. Just like the mixtures like homogeneous, heterogeneous, solutions homogeneous and heterogeneous, catalysts are also of two types, homogeneous catalyst and heterogeneous catalyst. So we will see what are homogeneous and heterogeneous catalyst. Homogeneous and heterogeneous catalyst. We know homo means same, that is uniform, similar. So homogeneous catalysts are those where the reactants and catalyst are in the same phase. So how do I say they are in the same phase? That is when both are in solid, or the reactants and the catalyst are in liquid phase, or they are in the gaseous phase. So here you can see oxidation of sulfur dioxide is giving sulfur trioxide in the presence of nitric oxide, that is NO. Nitric oxide is also in the gaseous phase, my reactants are also in the gaseous phase. So here when the reactants and the catalyst are in the same phase, we call those catalysis as homogeneous catalysis. Another example is hydrolysis of sugar. You can see sugar reacting with water in the presence of mineral acid, that is H plus ion. So, that is also in the liquid phase, and my reactants are also in the liquid phase, which is giving the products. I have glucose and fructose. So, homogeneous, now you understood both the reactants and the catalyst are in the same phase. So, what should be heterogeneous? Hetero means different, something not similar. So, heterogeneous catalysts are those where the reactants and the catalyst are in different phase. So, again the same example, sulfur dioxide, when it is getting oxidized to sulfur trioxide, instead of nitric oxide we can also use platinum, which is a solid. So, here platinum acts as a catalyst which is in the solid phase. You can see here sulfur trioxide or dioxide in the gaseous phase. So, when the reactants and the catalyst are in different phase, you call it as heterogeneous catalyst. Another example is a familiar example for you. We have learnt about Haber's process, production of ammonia, where nitrogen combines with hydrogen in the presence of iron, soft sponge iron, which is a solid again, giving me the product ammonia. So, here you can see this is in the gaseous form and my catalyst in the solid form. So, these are the two important types of catalyst. Now, we will learn about adsorption theory, that is the mechanism of heterogeneous catalyst. We will learn about adsorption theory of heterogeneous catalyst. Heterogeneous catalyst or any catalyst, how they play a role in the adsorption process is what we are going to see now. Children, we have been learning that adsorption process is an exothermic process. That is, because of the residual forces or unbalanced force on the surface of the adsorbent, there is an attraction on the molecules on the surface, and that is why the adsorption takes place and it releases heat. This is what we have learnt. But how does this happens is what we are going to see. Now, this is my catalyst. Any catalyst apart from the bulk, it will be having free valencies on its surface. That is, in a catalyst, the surfaces which are exposed outside rather than in the bulk, there will be free valencies, means free active centers, where when it gets exposed to a gas molecule or a reactant, the reactant can come and get adsorbed on the surface of the catalyst. So, that is what we are going to see. The first step of adsorption theory is diffusion of the reactant molecules. A and B are my reactant molecules. So, when A and B are combining together, it should give me AB as a product. But how does this happens? A and B, when they get exposed to a catalyst, they get diffused on the free centers which are available on the catalyst surface. So, adsorption of the reacting molecules, A comes and attacks one center, B comes and attacks one center. After that, what happens? Now, AB has to form a product. So, if AB has to join, they should join and they should make a product. But before joining, making a product effectively, they form a complex which is called as an intermediate. We call intermediate as a state which is not stable, that is, which do not stand for a long time. So, what happens here? When A and B get diffused or adsorbed on the catalytic surface, they form a temporary chemical bond. A temporary bond is formed between A and B now, and then this A and B becomes stronger, the bond becomes stronger, and which becomes weaker? The bond between A and catalyst center, B and catalytic center. So, AB forms a bond which becomes stronger, and then the last step is becoming desorption of the product molecules. What is desorption? Opposite of adsorption. Adsorption is getting accumulated, desorption is getting released, moving away from the catalyst. So, they break the bond between A catalyst, B and catalyst, and that is how the catalyst is obtained in the same way, chemically, quantitatively unchanged, and I get my desired product. This is called as an adsorption theory of heterogeneous catalyst. Now, you will watch a video to understand the mechanism of heterogeneous catalyst with a catalytic center.
the adsorption theory of heterogeneous catalysis. The colorless liquid in this beaker is hydrogen peroxide. Do you know that it forms water and oxygen at room temperature? However, we do not notice it since the reaction is extremely slow. If a catalyst such as copper filings is added to hydrogen peroxide, then the reaction rate increases tremendously and we can see bubbles of oxygen gas. This reaction is an example of heterogeneous catalysis. In heterogeneous catalysis, the reactants and the catalyst differ in phases. Is the hydrogenation of vegetable oils in the presence of finely divided nickel an example of heterogeneous catalysis? Let us understand the mechanism of heterogeneous catalysis. What is the mechanism by which a catalyst alters the rate of a heterogeneous reaction? According to the adsorption theory of heterogeneous catalysis, the reactants get adsorbed on the surface of the solid catalyst. Due to high concentration, the frequency of collisions between the reactants increases, and the reaction proceeds at a faster rate. There is another theory that explains the mechanism of heterogeneous catalysis. It is called the intermediate complex theory. This theory suggests that a catalyst provides a lower reaction path and a lower energy barrier to bring about a chemical reaction that ordinarily requires high energy. This is possible because the catalyst forms an unstable intermediate compound with the reactant. Unfortunately, this theory fails to explain the action of catalytic poisons and activators. The modern adsorption theory is a combination of both these theories. According to this theory, the reactants first diffuse towards the catalyst. Inside a metal catalyst, each atom is linked on all sides. However, the atoms on the surface of the catalyst have free valencies. The reactants get adsorbed on the free valencies of the catalyst surface. These free valencies form loose and unstable chemical combinations with the reactants and are called intermediate complexes. This weakens the bonds between the reactants and they readily react with the adjacent molecules to form the desired products. The products so formed desorb and leave the catalytic surface open for fresh reactants. The effectiveness of a catalyst can be enhanced by increasing the number of free valencies. This is done by using it in the form of a very fine powder. The same principle is used in catalytic converters. Nano-sized particles of catalysts such as platinum, rhodium or palladium are coated on honeycomb-like ceramic structures. The exhaust fumes contain obnoxious gases such as oxides of nitrogen, carbon monoxide, and unburnt volatile hydrocarbons. These pass over the finely divided catalyst and get converted into harmless gases such as water vapor, nitrogen, and carbon dioxide. Let us summarize what we have learned in this module.
I hope you saw the video, you got an idea about how the catalytic centers are there and how the reactants come and attack. right? See, the reactants, when they come and get adsorbed on the surface of the catalyst, that reactant, when it forms a bond, it should not form so strong so that it cannot break the catalyst bond and move, because once after it forms a product, that catalytic center should be available for the new reaction, for the new reacting molecules. So that is what we are going to see in activity and selectivity. What is activity? Activity depends on the strength of chemisorption. What is chemisorption, children? We know chemisorption is a process which involves a chemical bond between the adsorbate and the adsorbent. So when I told you these are my catalytic center, so what happens here, when A and B are formed, the bond between A and the catalyst, B and the catalyst should not be so strong. If it becomes so strong, what happens? It becomes immobilized. It cannot break and form the product, or it cannot allow other reacting molecules to come and attack my catalyst. It does not give the active centers available. So activity is nothing but the reacting molecules which comes and get adsorbed on the surface of the free catalyst should not be so strong, but it should be strong in such a way that the reaction occurs. Example is hydrogenation reaction. You can see the catalytic activity, actually it increases when it moves from 5th group to 11th group, especially from 7th and 9th, like platinum and all, they act as a very good catalyst in the hydrogenation reaction. Next, what we are going to see is selectivity. What do you mean by selectivity? Highly selective. I am very sure that if I want this product, I will use only this catalyst. If I want another product, I should use a different catalyst. You be selective. No, if you want to go have Chinese food, you don't go to an Indian restaurant. If you want to have an Indian food, you don't go to a Chinese or Punjabi dhaba. So whatever is our need, whatever is our desire that we should yield, that we will be very selective. So that is called as selectivity. Ability to direct a reaction to get the desired product. You are directing the reaction. You decide which catalyst when I am going to use, the product I can get. Example, you can see carbon monoxide, when it reacts with hydrogen, all the three reactions you can see I am using the same reactant, but I am getting three different products. What is the reason? The simple reason is use of three different catalysts. If I use nickel as a catalyst, I get methane and water as my product. If I use copper or zinc oxide with chromic oxide, I get methanol. If I use only copper as a catalyst, I get formaldehyde. So depending on what product we want, we select the catalyst. So catalysts are highly selective depending on the product that we want, right? Or I can give you another in simple words, that the catalyst which I can use in this reaction, the same catalyst cannot be used for other reaction for the same purpose, because I may not get the same product. So catalysts are highly selective. So activity and selectivity, I hope you understood. Then we will go for shape selective catalyst, which are called as zeolites. We will learn about shape selective catalyst. So we saw what is an activity, what are selectivity. Shape selective, from the name it is very clear that it depends on the shape or size. So this catalyst is depending on the pore structure of the catalyst. What do you mean by pores? Pores are nothing but small holes. Micropores means small thin holes which are available on the catalyst surface. So this catalyst depends on whether the more is the pores present on the surface of the catalyst. It also depends on the size of the reactant and the product. Size, when I say shape of the reactant and the product. Such catalyst we call them as zeolites or shape selective catalyst. So shape selective catalyst are those which depends on the pore structure of the catalyst and also the size of the reactant and product. The best example is zeolite. What are zeolites? Zeolites have a honeycomb structure with microporous aluminum silicate. Actually silicon atoms are present that is we call them as silicate with oxygen, but some of the silicon atoms will be replaced by aluminium atoms and it forms a structure like this, aluminium, oxygen, silicon. So, what happens here? Here the best use is in petrochemical industries for cracking hydrocarbons, that is for breaking of hydrocarbons. This zeolite is used. This is a common board question, children. ZSM, which converts alcohol into gasoline directly. That is, when you use ZSM 5, this is the name of a zeolite, it will immediately convert this alcohol into gasoline directly. So, what are shape selective catalysts? Example zeolite, and how they are used in the industry. It is very important board question. Now, we will get into enzyme catalyst. We are going to see about enzyme catalyst. Enzyme, we know what are enzymes. Enzymes are present in our body and it does a lot of magical work for us. Do you agree with me, children? Right. Now, imagine those enzymes are considered as catalyst for creating our life process. So, just appreciate God's creation for making our body undergoing so many chemical reaction in the presence of enzyme as a catalyst. So, what are these enzymes? These are nitrogenous organic compounds. Nitrogenous organic compounds, so nitrogen presence is there, which are being created by the living plants and animals. They are actually the protein molecules which are having a higher molecular masses and they act as an effective catalyst, and those enzymes which takes place in our body for the life process, we call them as biochemical catalyst. Bio something with respect to the biological activity, chemical because there is a chemical reaction that is happening and it acts as a catalyst. So, we call them as a biochemical catalyst. I have given just give few examples, some more are being jotted in your textbook, please go through that, children. Inversion of cane sugar, this is the best example I can give you which you have been learning from your 10th standard. So, sugar when treated with hydrolyzed with water in presence of invertase as an enzyme, you get glucose and fructose. So, here we use invertase as an enzyme. Milk, if you want to convert into curd, lactobacilli is used as an enzyme there. Stomach, we know what enzyme is there, pepsin, and you have in pancreas trypsin, which all is converting proteins into amino acids, and on hydrolysis so many process. So, some of the examples are only I have given, you have to see some more examples from your textbook to make sure that if anything is asked in extra, then you should be able to answer it. So, as a part of a knowledge, please go through the text for more examples. Now, we will learn about the characteristic features of enzyme catalyst and then we go for the mechanism. With that, we will stop the class for. We shall see the characteristic features of enzyme catalyst. Enzyme catalysts are highly efficient. What do you mean by efficiency? Efficiency means what is the rate that I can do. Say I can ask, let us take Archana. If I ask Archana to complete the work, can you write some 20 pages? She may write 30 pages and give me. But some other child can write even 50 pages and give me. So, efficiency is nothing but how much I can do the work productively. So, this catalyst, one enzyme catalyst can give 1 million molecules of reacting species. So, that much efficiency is a enzyme catalyst, and they are highly specific. Specific we learned on selectivity. You remember, children, I cannot use the same catalyst for all the purposes. Similarly, if one enzyme is used for one activity, I cannot use the same enzyme for the other activity, other reaction. Pepsin should be used in stomach, trypsin should be used in pancreas. I cannot put pepsin in my lungs or trypsin in my saliva. Enzymes are totally different. So, they are very, very specific, or I can say selective. Highly active at optimum temperature. What does it mean? What is optimum temperature? At a particular definite temperature, the rate of this enzyme, that is this enzyme becomes so energetic that they react so vibrantly. If you increase or decrease that particular temperature, the rate of that enzyme catalyst actually decreases. Now that optimum temperature is 310 Kelvin. So at 310 Kelvin, this rate of enzyme catalysis is actually high at that optimum temperature. Next is highly active at optimum pH. Just like temperature, at around 5 to 7 pH range, these enzyme catalysts are very active. That is, the rate of the function of this catalyst is very high. The next two are very important: influence of activators and coenzymes. What are activators? Activators like metal ions like sodium ions or manganese ions, when they are along with this catalyst, the rate of the reaction of this catalyst, the function of this catalyst actually increases. And what are coenzymes? Coordinate, cooperate, company. When I say coenzymes, nothing but a friend. So when this enzyme is joined with another enzyme like protein or a vitamin molecule, they actually get charged. You always be happy when you have your friend with you. You try to do more work, more assignments, more homework. But if your friend is not there, you become so lazy. Same thing happens here. So these enzyme catalysts, actually they become so energetic, their rate of reaction increases when they have their coenzymes with them. But the same thing is opposite with the influence of inhibitors and poisons. What are inhibitors? Inhibit means stop, avoid, prevent, right? So inhibitors and poisons, what they do is they start interacting with this enzyme catalyst. There are actually functional group present in this enzyme catalyst, because I told you they are nitrogenous organic compounds. So those, when they react with this poisons or inhibitors, they decrease the reactivity of the enzyme catalyst and make them decrease the rate of reaction. So these are the most important characteristic features of enzyme catalyst. Now we will learn about the mechanism. After the mechanism, I will show you a video. There is a diagram given in your textbook. Okay, it looks like we play a video game, you know, right? I forgot that name. Chuck, 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 buck, 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 buck. It starts biting like this. It goes. I don't know the name. I forgot, children. It doesn't matter. I am not drawing the diagram because I don't think so I will be able to do it. So I will be showing the video anyways for you for better understanding. I have just written the steps. Actually, what happens? These enzyme catalysts will be having, they are actually in the form of a colloid particles. Okay, so those particles will be having active centers. They are having some irregular shape. So when this enzyme comes in contact with my reactant, I call this also as reactant or substrate. Okay, substrate. So when this substrate comes in contact with my enzyme, it actually gets fit into this enzyme. This is my substrate, this is my enzyme. It comes in, gets fit like this. So what happens? Just like a key, when you put it into a lock, it gets fixed. So it gets fixed like this and it forms a activated complex, which is an intermediate. So binding of the enzyme to the substrate, binding means joining, it just joins like this, and this is a temporary complex. The next one is decomposition of the complex. It just breaks, it gives my product. After getting combined with the enzyme, it forms my desired product and get back my enzyme back with a whatever is I have given, that same composition I get it back after the reaction gets over. So such a process we call it as an enzyme action as a catalyst. See, there is a table given in page number 133. Some of the important process and the catalyst used, you can see here. You have a Haber's process, Oswald process, contact process. All the three process and the catalyst used in each process are very important for exam. So learn that, children. You will be watching a video now for understanding the mechanism of enzyme catalyst. And still, if you have any doubts, please call me. And still, very few children only call me and interact with me. Many of you are still not there, not coming up. So I want a good participation from your side as well. Now you watch the video and make sure that you write the notes wherever it is necessary. Okay, we'll get back into next chapter, next topic, that is colloids, in the next class. So until then, take care, stay home, stay safe, be happy, right? Keep smiling. Thank you, children. Take care. Bye.
Mechanism of enzyme catalysis. In a laboratory, the hydrolysis of proteins requires heating the protein with hydrochloric acid at a temperature of 110 degrees Celsius for a period of 24 hours. Do you know that the same reaction takes place in your body every day at a much lower temperature of 37 degrees Celsius? Within minutes, the proteins in your gastrointestinal tract are broken down into their constituent amino acids. This is possible due to the catalytic action of enzymes. How do enzymes work? Let's find out. Enzymes are globular proteins which have a catalytic action. They increase the rate of biological reactions. For example, in the stomach, an enzyme called pepsin acts as a catalyst and helps convert proteins to peptides. All enzymes have a high molecular mass and are colloidal in nature. On the colloidal surface of enzymes, there are multiple cavities called active cavities. These cavities possess different active groups such as NH2, SH, OH and COOH. Such sites act as the active centers on the surface of the enzyme particles. In a biochemical reaction, the reactant on which the enzyme acts is known as the substrate. The substrate molecule is much smaller than the enzyme and it binds to its active site. The active site of an enzyme shows a high level of substrate specificity. An enzyme will bind only to specific substrates. Therefore, thousands of enzymes occur in nature and each enzyme catalyzes a different biochemical reaction. Once a substrate molecule binds to an enzyme at its active site, the catalytic activity of the enzyme converts it into the desired product. The newly formed product then leaves the active site of the enzyme. Now, the enzyme is once again ready for catalysis. This mode of enzyme action may be expressed as enzyme E plus substrate S gives the enzyme substrate complex ES. It is formed due to interactions such as hydrogen bonding, ionic bonding, and van der Waals interactions. The enzyme converts the substrate into the products. This activated complex then decomposes to give the products. The formation of the enzyme substrate complex is the most important step in enzyme catalysis. The specific action of an enzyme with a single substrate can be explained using a lock and key analogy, which was first postulated in 1894 by Emil Fischer. In this analogy, the lock is the enzyme and the key is the substrate. Only a key with the correct size and correct position of teeth fits into the keyhole of its complementary lock. Similarly, only a specific substrate with the correct size and shape fits into the active site of the enzyme to form the enzyme-substrate complex. The enzymes act as biocatalysts. They lower the activation energy of biochemical reactions. Consequently, reactions can take place at lower temperatures and at faster rates.
Now let us summarize what we have learned.